welcome to this session on forming internal threads with taps to standard size for both through holes and blind holes. Let us begin with the session.
Let us look at the objectives of this session. At the end of this session, you will be able to chamfer the holes for tapping, fix the job in bench-wise, determine the tap drill sizes for internal threading, select the tap set, cut internal threads in through and blind holes using hand tap and tap wrench. Let us look at the tools required for the procedure. Steel rule, bench-wise, tri-square, files of different grades and sizes, marking media, dot punch, ball peen hammer, anvil, surface table, angle plate, vernier height gauge, drills of various sizes, drilling machine, chuck key, countersink tool, tap set M10 and M12, tap wrench, vernier caliper, lubricating oil. Let us now learn to prepare the specimen for cutting internal threads. Check the size of the raw material using steel rule. File all the faces using bastard file. Ensure parallelism and perpendicularity using a tri-square. Apply marking media on face A. Mark to size of 60 mm by 60 mm using vernier height gauge. Witness mark on the workpiece using dot punch and ball peen hammer on an anvil. File and finish to the respective sizes using various grades of files. Ensure parallelism and perpendicularity using tri-square. Check the dimensions using vernier caliper. Again, apply marking media on face A. Clean the surface table and angle plate. Ensure that all the moving components of the vernier height gauge are functional. Support the job with the help of an angle plate on the surface table. Mark parallel lines at 20 mm and 40 mm from face B using vernier height gauge. Mark parallel lines at 20 mm, 40 mm from face C using vernier height gauge. Mark the drill hole centers 1, 2, 3 and 4 using center punch and ball peen hammer on an anvil. First, determine the tapping drill size using the table for tapping drill sizes or by calculation. For example, drill size of M12 and pitch 1.75 mm is drill size is equal to size of the thread minus pitch of the thread, which is equal to 12 minus 1.75. So the drill size is 10.25 mm. For example, the drill size of M10 and pitch of 1.5 mm is drill size is equal to size of the thread minus pitch of the thread, which is equal to 10 minus 1.5. So the drill size is 8.5 mm. Hold the job in the drilling machine vise. Fix 3 mm drill bit and drill 2 through holes on points 3 and 4. Fix 6 mm drill bit and drill pilot holes on points 3 and 4. Fix 8.5 mm drill bit and drill through holes on points 3 and 4. Let us now learn to set the depth stop arrangement to drill blind holes. Fix the 3 mm drill bit into the spindle and drill until the full diameter is formed on points 1 and 2. Keep the workpiece in contact with the drill bit and adjust the depth on the scale using the knob provided. Also add for error if any. For an error of 2 mm and a required depth of 14 mm, adjustment of 16 mm should be done on a scale while the workpiece is in contact with the drill bit. Set the spindle stopper lever so that the drilling feed stops when the mark reaches 0. Set the feed handle for auto feed and switch on the machine. Fix 6 mm drill bit and repeat the above procedure to obtain a blind hole of 14 mm depth on points 1 and 2. Check the depth of the pilot drilled hole using a vernier caliper. Fix 8.5 mm drill bit and repeat the above procedure to obtain a blind hole of 14 mm depth on points 1 and 2. Fix 10.25 drill bit and repeat the above procedure to obtain a blind hole of 14 mm depth on points 1 and 2. Ensure 14 mm depth of blind hole drilled using a vernier caliper on points 1 and 2. Fix the countersink tool into the spindle of the drilling machine. Chamfer both the ends of the through holes at points 3 and 4. Chamfer the open end of the blind holes at points 1 and 2. File and deburr in all the surfaces of the job, cutting internal threads in through holes. Hold the workpiece in the benchwise such that the top surface is slightly above the jaw. Fix the M10 first taper tap in the wrench. Exert steady downward pressure and turn the tap wrench slowly in a clockwise direction to start the thread. Make sure the tap is vertical with the help of a small tri-square. Turn the wrench slowly so that the pressure exerted is balanced on both the sides and continue cutting the thread. Turn backwards frequently for about quarter turn to break the chip. Cut the thread until the tap is full inside the hole being threaded. Finish the thread using second, intermediate and third bottoming or plus tap. Remove the chips with a brush. Check the threaded hole with a matching screw. Cutting internal threads in blind holes. Remove the metal chips, if any, from the blind hole by turning it upside down and slightly tapping it on a wooden surface. Fix the M12 first taper tap in the wrench. Screw a matching nut on the first tap to the required depth so as to act as a depth stop arrangement. Thread the blind hole until the nut touches the workpiece surface. Use intermediate and bottoming tap to finish the thread cutting operation along with the nut as depth stop arrangement. Check the threaded hole with a matching screw. Deburr the entire workpiece with the help of a small flat file. Apply lubrication and preserve for evaluation. Do's and don'ts. A very small wrench will need greater force. A very large tap wrench will not give the required feel while tapping. Always use cutting fluid while cutting the thread. Do not try to clear the chips by blowing while tapping a blind hole. Remove the chips from the blind hole frequently using a flattened and bent wire. Clean the tap set with a brush after finishing the thread cutting operation.
To recap, we have learned to chamfer the holes for tapping, fix the job in benchwise, Determine the tap drill sizes for internal threading. Select the tap set. Cut internal threads in through and blind holes using hand tap and tap wrench. So that's all about forming internal threads with taps to standard size. Hope you have understood all the concepts and exercises. See you in the next session.